Hello everyone, welcome back to the tutorials on Ansys Workbench. In today's session, I am going to show you how to solve a stepped bar subjected to a thermal loading. In this case, I want to find deformation as well as maximum stress induced in the subject stepped bar subjected to only thermal loading. As in the previous videos you have seen, the bars subjected to the mechanical loading. So in this case we have only thermal loading. So let's begin. This is the problem statement. Determine the nodal displacement and maximum stress in a 1D stepped bar. So remember this 1D stepped bar made of steel and aluminum subjected to thermal load and the boundary conditions as shown. The initial temperature of stepped bar is 20 degrees Celsius and final temperature is 80 degrees Celsius. Young's modulus of steel 200 GPa, Young's modulus of aluminum 70 GPa, area of steel 1000 mm square, area of aluminum 500 mm square, and coefficient of thermal expansion for steel 11.7 e power minus 6 per degree Celsius, and coefficient of thermal expansion for aluminum 23 e power minus 6 per degree Celsius. So this is the stepped bar given. Both ends of the bar is fixed and this stepped bar is subjected to thermal loading. Initial temperature is 20 degree Celsius and its final temperature is 880 degree Celsius. And the length of steel is 500 mm, length of aluminum is 250 mm. So you can create this 1D stepped bar either using space climb geometry workbench, or you can also create this 1D stepped bar using design modeler workbench. So let's begin with the Ansys workbench. So as in this case it is steady state thermal loading problem. So select this and drag it on the screen. If you want you can rename this as stepped bar. Double click on this stepped bar. Thermal loading. Next, edit engineering data. So here by default you can see the properties of structural steel. So these properties are as default submitted by Ansys. Along with this structural steel, I want aluminum alloy also. So to add that material, so go for engineering data sources, click on general materials, search in the below window, you will find aluminum alloy. You just click plus button to add the material to engineering data. So now go back to engineering data sources. So you can find aluminum alloy as well as structural steel. So first click on aluminum alloy. If you are unable to find all these parameters here, you just click on filter engineering data. So it will expand the parameters. Here I want to input the data for coefficient of thermal expansion as well as Young's modulus. So let's see the coefficient of thermal expansion given in the problem for aluminum alloy. So it is 23 e power minus 6 per degree Celsius. So it is 2.3 e power minus 5 per degree Celsius. It is correct. Next, Young's modulus in megapascals, it is 0.7 E5. Next, click on structural steel. Coefficient of thermal expansion 11.7. So change this to 11.7 e power minus 6. Okay, 11.7 e power minus 6. Next, Young's modulus in megapascals. So this is correct. So now go back to your project workbench. You can see the green color tick mark on engineering data. So next right click on geometry. So I am using space claim geometry workbench to create 1D stepped bar. So in the problem it is clearly mentioned as 1D element. So I want to create this stepped bar by using 1D element only. So now go back to the space claim geometry workbench. So click on y-axis in the compass here. Now I am going to create 1D elements. Select a line from the origin. So length of steel is 500. Enter. Again aluminium is 250. Enter. Next I want to assign the cross sections for this 1D elements. To do that, go for prepare profiles. So I will set this as circular profile. So first circle, you can check under the beam profile. Circle is added over here. Just click on circle. Here it is asking for area. So it is 1000. Next, again go for circle and choose one more circle. So circle 2 will be added under this tree. Change this area to 250. Okay, again go back to sketch and end sketch editing. So 2 circle cross sections has been added successfully. So now I want to assign which line is having a which cross section. To assign that, just expand these curves. So click on first line and go for prepare and change this to circle. Okay. Next, click on the screen and again select the remaining line. See, the line has been selected here. Click on circle 2 and click on the screen. So now the cross sections has been assigned to the line 1 and line 2 successfully. Next, click on this design 1. I want to share this topology for the next steps. So it is defined as none. So change this to share. So now this topology will be shared for the further steps. Now go back to the project workbench. You can see the green color tick mark on the geometry. So it is successfully completed. Next, right click on model and click on edit. So this is the process chart you can see over here. Let's check one by one. So your geometry import is successful. Next, click on the geometry and click on the SYS. So as we have circle 1 and circle 2, I need to assign the material for this beam. So for this beam circle, so this is the larger line you can see over here. This is structural steel as given in the problem, 500 mm. So it is assigned as structural steel. Next, click on second beam line. Next, change this to aluminum alloy. Okay. So this is done. So materials, we have two materials, aluminum alloy and structural steel. So close this. Next, click on mesh. Right click, generate mesh. So as it is a simple geometry, we don't want to define any elemental size. It will calculate on its own and it will create the mesh. So meshing is done. So right click on the screen, go for view and select front view. So now again right click on steady state thermal, insert temperature. So it is asking for the geometry, click on first line, apply. So its magnitude is 80 degrees Celsius. Okay, repeat the same procedure, insert temperature, choose the second line, apply, and again its magnitude 80 degrees Celsius. Okay, and again click on initial temperature is 20 degrees Celsius. Okay, now I want to fix the supports on both ends. To do that, you need to select the analysis for static structural. So now I want to fix the supports. Right click, insert fixed support. You can choose this vertex and also this vertex. You can press Ctrl and you can select at a time. Yeah, so apply. Okay, I think it's fixed. Next, right click on static structural, just import the load from steady state thermal. If you are not importing the load from steady state thermal, it will ask you for the load. No point load has been defined, means the static structural is different, the steady state thermal is different. If you want to import the steady state thermal loading to the static structural analysis, you need to right click on static structural, you need to import the load. Now it is imported successfully. Now again click on solution, insert deformation total. So whichever the results you want to see, you can choose it from the solution and you can insert it. So in this case I want beam tool for direct stress. If you want, you can select this and you can delete this if it is not required. And again right click on solution and you can click on solve. So your solution is done. You just click on total deformation. You can see the total deformation. So minimum is 0 and the maximum is 0.0002391 meters. It is in meters. If you want to view it in millimeters, you can change this to millimeters. Okay, so 0.2391 millimeter. Again, if you want, you can play the animation. And if you want stress, you can click on direct stress. So this is minimum value and this is the maximum value, and you can play the animation. And when you click on solution information, it will give you all the details of the analysis. And if you want to generate the report, you can click on report preview and your report will be ready. If you want, you can print it or you can share it. So that's all for today's session. Thank you all. We'll see you in the next video.